Welcome to Part 6 of the Android Interview Series 2024, focusing on Kotlin Flows. This series is designed to help you master key concepts for Android interviews, covering everything from basics to advanced topics. In this episode, we'll dive deep into Kotlin Flows, exploring their characteristics, types, and practical usage. Whether you're preparing for your next interview or aiming to strengthen your Android development skills, this guide will walk you through the essentials and advanced techniques. Let's start by understanding what a flow is and why it's a game changer for asynchronous data handling in modern Android apps. Flow in Kotlin represents a stream of data that can be computed asynchronously. It allows you to emit multiple values over time in a sequential and reactive manner. Flows are designed to handle asynchronous data streams, emitting values one after another and suspending until the previous emission completes. This provides a natural non-blocking way to manage data. Flows automatically handle backpressure by suspending emissions if the collector is slow, preventing resource overload. Importantly, flows are cold, they don't emit values until actively collected, starting fresh each time. This is different from hot streams like LiveData or RxJava subject, which emit values regardless of active observers. Kotlin offers several ways to create flows, each suited to different use cases. The primary method is the flow builder, which lets you emit values asynchronously using the emit function. For example, you can emit numbers from 1 to 5 with a delay between each. The flowOf builder creates a flow from a fixed set of values, while converts collections or sequences into flows. These builders provide flexibility, allowing you to generate flows from various sources, whether dynamic or stat. Understanding these creation methods is crucial for implementing flows in real-world applications, enabling you to tailor data streams to your needs. Kotlin flows come in two main types, cold and hot. Cold flows don't start emitting values until a collector actively collects them. Each collector gets its own instance and the flow starts from scratch every time. This is ideal for scenarios where fresh data is needed for each subscriber, such as database queries or network requests. Hot flows, on the other hand, emit values independently of collectors. Once started, they continuously produce data shared among all collectors, similar to broadcasting. New subscribers receive only the latest emissions, missing any past values. Hot flows are perfect for UI state updates or event broadcasting. Cold flows are lazy and don't perform any work until there's a demand for data. Each collector receives an independent stream, starting from the beginning every time. This makes cold flows suitable for repeatable sources, ensuring each subscriber gets fresh data. For example, when querying a database or making network requests, cold flows guarantee that each operation starts anew. This behavior is essential for scenarios where data integrity and freshness are critical, allowing developers to manage streams efficiently and avoid unintended data sharing between collectors. Hot flows emit values regardless of active collectors. Once started, they continuously produce data, sharing it among all subscribers. This is similar to broadcasting, where new collectors receive only the latest emissions. Hot flows don't restart emissions for each new collector. Instead, all collectors receive data from the same ongoing flow. This makes hot flows ideal for scenarios like UI state updates or event broadcasting, where all subscribers need access to the latest value. Understanding the distinction between cold and hot flows helps developers choose the right approach for their application's needs. Airflow and stateflow are both types of hot flows, but they serve different purposes. Stateflow is designed to hold and emit state updates, always maintaining a single current value. New collectors instantly receive the latest value, making stateflow ideal for UI state management. Shared flow, on the other hand, is more general-purpose, broadcasting events or shared data to multiple subscribers. It allows configuration of replay and buffering, ensuring emissions aren't lost if collectors are slow or absent. Shared flow doesn't retain a single current value, making it suitable for event streams rather than continuous state. Stateflow is a specialized hot flow that holds a single current value. It emits the latest state to new collectors and allows direct reading and updating of the value. Changes are updated immediately, and new collectors always receive the latest value upon subscription. Stateflow is exposed as immutable, so external subscribers can read but not modify the value. It's commonly used in view models to hold UI state, ensuring all consumers have the most recent data. This makes stateflow a reliable choice for managing a single source of truth in Android applications. Airflow is a general-purpose hot flow that broadcasts emissions to all subscribers. Unlike stateflow, it doesn't hold a single current value. Shared flow is highly configurable, allowing you to set replay and buffer options. This prevents emissions from being lost if there are no active collectors or if collectors are slow. Shared flow is best for representing events or streams of data that don't represent continuous state, such as notifications or one-time action. Its flexibility makes it suitable for scenarios where multiple subscribers need access to shared events. Terminal operators in Flow are responsible for collecting emitted values and performing final actions. They start the collection process, meaning the flow remains cold until a terminal operator is invoked. Common terminal operators include collect to list, to set first, last, single, reduce, fold, and count. Each operator serves a unique purpose, from gathering all items into a list or set to retrieving the first or last value to performing reduction or counting operation. Mastering these operators is essential for effectively processing data streams in Kotlin Flows. Collect operator is used to receive each emitted value from a flow and perform a specified action. For example, you can print each value as it's received. Collect is fundamental for processing flows as it triggers the emission of values and allows you to handle them in real time. Without collect, a flow remains cold and doesn't produce any values. This operator is often used in combination with other terminal operators to manage data streams efficiently. ToList operator collects all emitted values and stores them in a list, returning the list when the flow completes. This is useful for gathering items from a flow into a collection for further processing. The toSet operator works similarly, collecting values into set and eliminating duplicates. These operators are handy when you need to aggregate data from a flow, ensuring you have a complete collection of emitted values for later use. First operator returns the first value emitted by the flow and immediately cancels further collection. If the flow is empty, first or null returns null. The last operator collects all values and returns the last emitted value, throwing an exception if the flow is empty. Last or null returns the last value or null if the flow is empty. These operators are useful for scenarios where you need to retrieve specific values from a stream, such as the initial or final item. Single operator expects the flow to emit exactly one value. If the flow emits more than one value, it throws an exception. Returns null if the flow is empty, and if there's only one item, it returns that item. This operator is ideal for cases where you expect a single result from a flow, ensuring data integrity and preventing unexpected multiple emissions. Deuce performs a reduction operation, accumulating values as they are emitted by the flow. It applies an accumulator function to combine values and returns the final result. Fold is similar but allows you to specify an initial value for the accumulation. These operators are powerful for processing streams, enabling you to compute sums, counts, or other aggregated results efficiently within a flow. The count operator counts the number of items emitted by the flow that satisfy a given predicate. If no predicate is provided, it counts all items emitted. This operator is useful for filtering and quantifying data within a flow, allowing you to quickly determine the number of relevant items in a stream. Launch an operator collects the flow within a specific coroutine scope without blocking the calling coroutine. It's often used with hot flows when you want to start collecting in a different coroutine scope. Unlike other terminal operators, launch-in doesn't wait for the flow to complete but runs it in a separate coroutine. This enables concurrent data processing and efficient management of multiple flows. State-in and share-in are operators used to convert a flow into a hot flow that can be shared among multiple collectors. State-in converts a cold flow into a state flow, retaining the latest emitted value and always having a single current state. Share-in converts a cold flow into a shared flow, allowing configuration of replay and providing flexibility for event-driven flows. Understanding these operators helps you transform flows for shared state or event management in your application. State-in operator converts a cold flow into a state flow, which retains the latest emitted value and always has a single current state. When a new collector starts collecting, it immediately receives the latest value held in state flow. State-in requires an initial value, ensuring the flow always has a value to emit. This operator is ideal for state management, providing a single source of truth for your application's current state. Share-in operator converts a cold flow into a shared flow, allowing you to configure how many values to replay and manage event-driven flows. Unlike state-in, share-in doesn't require an initial value and is used for handling events rather than holding state. It's suitable for event streams or data that needs to be replayed partially, providing flexibility for managing shared events among multiple collectors. Jetpack Compose offers several ways to collect flows. The collect-as-state extension function is ideal for collecting a state flow in a compose function, converting it into a compose state and automatically recomposing the UI when the flow emits a new value. For lifecycle-aware collection, use collect-as-state with lifecycle, which only collects when the composable is in an active lifecycle state. Launch effect with collect is used for event flows, allowing you to collect values inside a composable without recomposing on every emission. Backpressure occurs when the producer emits items faster than the consumer can process. Kotlin's Flow API provides operators like buffer, which adds a buffer to flow, allowing the producer to emit items without waiting for each to be processed. The conflate operator keeps only the most recent value, dropping previous unprocessed values. These strategies help manage memory usage and ensure smooth data flow, preventing delays or overflow. Kotlin provides several operators to combine multiple flows. The zip operator pairs emissions from two flows, emitting values as pairs or transformations. The combine operator takes the latest value from each flow and emits a new value whenever any flow emits. Flat merge collects from multiple flows concurrently, merging their emissions into a single flow. Merge interleaves emissions from multiple flows, emitting each value as produced. These operators enable complex data stream management, allowing you to react to and merge multiple sources efficiently. Kotlin Flows offer flat map concat, flat map merge, and flat map latest for advanced stream manipulation. Flat map concat concatenates flows sequentially, waiting for each inner flow to complete before moving to the next. Flat map merge collects from multiple flows concurrently, merging their emissions as they come. Flat map latest cancels the previous flow whenever a new flow is emitted, only collecting the latest. These operators provide powerful ways to handle complex data streams and manage concurrency. Handling exceptions in flows is crucial for robust applications. The catch operator is the primary way to handle exceptions, catching errors thrown by the upstream flow and allowing you to emit alternative values. The onCompletion operator is triggered when the flow completes, enabling cleanup actions or logging. Emit catching allows granular exception handling within specific parts of the flow. These tools ensure your flows remain resilient and can recover gracefully from errors. Retry operator allows you to retry a flow when an exception occurs, making it useful for transient errors like network issues. You can specify the number of retry attempts and use a predicate to determine which exceptions should trigger a retry. This operator enhances the reliability of your flows, ensuring they can recover from temporary failures and continue processing. Implementing a debounce mechanism for user input using flows helps prevent excessive emissions and improves performance. By using operators like debounce, you can ensure that only the latest input is processed after a specified delay, discarding rapid intermediate emissions. This is particularly useful for search fields or real-time filtering, where you want to avoid unnecessary processing and provide a smooth user experience. LiveData and Flow are both used for data streams in Android, but they differ in key ways. LiveData is a hot stream emitting data as soon as it has an active observer and continuing even without observers. Flow is a cold stream only emitting data when collected and restarting each time. LiveData is lifecycle aware by default, while Flow requires manual lifecycle management. Flow offers built-in error handling and backpressure management, making it more flexible for asynchronous data handling. LiveData is tightly integrated with the Android lifecycle, automatically starting and stopping observation based on the UI component's lifecycle. Flow, however, is not lifecycle aware by default. When using Flow in Android, you must manually manage the lifecycle, such as using lifecycle scope or repeat on lifecycle. This distinction is important for ensuring data streams are managed correctly and efficiently within your application. LiveData doesn't have built-in error handling, requiring additional patterns for managing errors. Flow supports built-in error handling operators like catch, retry, and retry when, making it easier to handle exceptions and recover from failures. This makes Flow a more robust choice for scenarios where error management is critical, providing developers with tools to ensure data integrity and reliability. LiveData always observes on the main thread, simplifying UI updates. Flow allows explicit control over threading using the flow-on operator, letting you specify which dispatcher should be used for upstream operations. Flow also supports backpressure handling with operators like buffer, conflate, collect latest, and debounce, preventing missed updates or performance issues. This flexibility makes Flow ideal for complex asynchronous data streams. LiveData requires additional handling for one-time events like navigation or showing messages, often using patterns like single live event or event trapper. Flow is more suitable for one-time events, especially with shared flow or state flow, which allow configuration of replay behavior and finer control over event emission and collection. This makes Flow a better choice for managing events in modern Android applications. You can convert LiveData to Flow using the asFlow extension function and Flow to LiveData using asLiveData. This makes it easy to use Flow in lifecycle-aware contexts and integrate with existing LiveData-based architectures. Understanding these conversions helps you transition smoothly between data stream paradigms in Android development. Flow is a cold stream, starting emission on collection, while Channel is a hot stream emitting values immediately upon being sent. Flow has a single producer-consumer model, while Channel supports multiple producers and consumers, ideal for communication between coroutines. Flow starts and stops with each collection, while Channel remains open until explicitly closed. Flow offers rich operators for data transformation, while Channel provides basic send and receive method. Channels support concurrent producers and consumers, making them ideal for message passing and producer-consumer patterns. They use buffering to manage backpressure, such as buffered or conflated channels. Channels don't have built-in error handling but can propagate exceptions. They allow values to be received by multiple consumers, providing flexibility for communication between coroutines. Flow is ideal for data streams, transformations, and UI updates. It offers built-in suspension to handle backpressure, rich operators for data manipulation, and robust error handling. Flow can only be collected once per collector, ensuring sequential processing and data integrity. Its features make it well-suited for managing asynchronous data streams in modern Android applications. Unit testing flows is essential for ensuring reliability and correctness. For example, a user view model might fetch a list of users from a repository exposing a flow of user data. Testing involves defining the view model, setting up test dependencies, and using tools like Turbine to verify flow emissions. This approach ensures your flows behave as expected and helps catch issues early in development. Testing flows typically involves 3 steps: defining the view model, setting up test dependencies, and testing the view model using Flow and Turbine. This structured approach allows you to simulate data streams, verify emissions, and ensure your application logic is robust. Proper testing is key to building reliable Android apps that handle asynchronous data correctly. Kotlin Flows provide a powerful, flexible way to handle asynchronous data streams in Android. Understanding their types, operators, and integration with Jetpack Compose and other Android components is essential for modern development. With robust error handling, backpressure management, and testing strategies, Flows enable developers to build responsive, reliable apps. Mastering these concepts will give you a strong foundation for Android interviews and real-world projects. Preparing for Android interviews, focus on understanding the core concepts of Kotlin Flows, their operators, and practical usage scenarios. Practice implementing flows, handling exceptions, and managing backpressure. Review differences between flows, LiveData, and channels, and be ready to discuss their advantages and use cases. Testing flows is also important, so familiarize yourself with unit testing strategy. These tips will help you confidently tackle interview questions and demonstrate your expertise. Kotlin flows are used in a variety of real-world applications, from managing UI state in Jetpack Compose to handling network requests and database queries. Their flexibility allows developers to build scalable, maintainable apps that respond efficiently to asynchronous data. By leveraging flows, you can create robust architectures that handle complex data streams and provide a seamless user experience. Android developer community actively shares insights and best practices for using Kotlin Flows. Platforms like Medium and Pro Android Dev feature articles from professionals and Google developer experts, offering tips, code snippets, and real-world examples. Engaging with the community helps you stay updated on the latest trends and solutions, enhancing your skills and knowledge. Explore recommended resources for mastering Kotlin Flows, including guides on certificate pinning, shared flow usage, and clean architecture. These resources provide comprehensive coverage of advanced topics, helping you deepen your understanding and apply flows effectively in your projects. Continuous learning is key to staying ahead in Android development. For further reading, check out articles on top Kotlin code snippets, coding practices, and clean architecture struggles. These resources offer practical advice and real-world experiences from seasoned developers. By exploring these materials, you can gain valuable insights and improve your coding skills, preparing you for both interviews and professional growth. Thank you for joining this deep dive into Kotlin Flows as part of the Android Interview Series 2024. We've covered the essentials, advanced concepts, and practical applications of flows, equipping you with the knowledge to excel in interviews and real-world development. Remember, continuous practice and engagement with the community are key to mastering these skills. Happy coding and best of luck in your Android journey.